This is 2011 FRQ number 1. Starting this year, the calculator questions are now down to 2, and then the non-calculator questions are now up to 4 questions, right? So it's going to be a 2 and 4 instead of the old 3 and 3. Okay, so the first problem is a graphing calculator allowed. So between 0 and 6, a particle is moving along the x-axis. The particle's position, x of t, is not explicitly given. The velocity is given by v of t equals 2 sine e to the t over 4 plus 1. The acceleration is given by a of t, this equation, and the initial condition here, x of 0 equals 2. Okay, first question, is the speed of the particle increasing or decreasing at time equals 5.5? Give a reason for your answer. In an earlier set of FRQ, I kind of briefly went over this, that if the acceleration and velocity are the same sign, meaning they're both positive or both negative, they're working with each other, they're helping each other, therefore the speed will increase. If velocity is positive but acceleration is negative, they're going to be working against each other, so that your speed is going to decrease. So in short, if velocity and acceleration have the same signs, they're both positive or both negative, the speed will increase. If they have opposite signs, the speed will decrease. All right, so then the easiest way to go about this is plug in 5.5 into v of t and plug it into a of t, see if I get a positive or negative answer, and see what if the speed will be increasing or decreasing. So part A, we are going to plug in v of 5.5, that's 2 sine of e to the 5.5 over 4 plus 1, and a of 5.5, which is 1/2 e of 5.5 over 4, cosine of e to the 5.5 over 4. All right, so what am I going to get? Calculator time. This is not very doable but without it. 2 sine e of 5.5 divided by 4, close parentheses. Close another parentheses because that's all the sign, and then plus 1. That gives me a negative answer. I don't even care about the answer. I know it's negative. All right. Now, what about the acceleration? So 1/2, which is 0.5, e to the 5.5 over 4, close parentheses, cosine of e to the 5.5 over 4, close, enter. I get another negative answer. So since they are both negative, they're the same sign, then the speed will increase. Okay, and that's it for part A. All right, part B, find the average velocity of the particle in the time period between 0 to 6. So average velocity, average speed, similar idea. It's the total distance over the total time. Well, I don't have the position, so the only way to get how much distance has been traveled will be the integral of the velocity that will give me the total distance that's traveled in v of t, right? So if we want the average velocity, we're going to take the total distance, so 0 to 6, 2 sine of e to the t over 4 plus 1 over total time, which is 6, right? So 1 over 6. That will give me the average velocity. So I'm going to put in this integral first, right? So math 9, 2 sine e to the x over 4, close, plus 1, comma x, comma 0, comma 6. All right, so this is my function, double check, 2 sine e to the x over 4, close my parentheses, plus 1, okay, enter. That's the total distance. Now divide by 6, that's total time. So my average velocity is 1.949. Let's take a quick look. I don't see any units, so I'm guessing I don't need to do much about that. If there are units here, then make sure you put like distance over time, okay? All right, part C is a little trickier. Find the total distance traveled by the particle from the time t equals 0 to t equals 4. So if you were to graph this out, you will see something that's a little bit interesting. So let's graph, when I say total, that's kind of something you need to watch out for. It's a key word. All right, so e to the x over 4, close, plus 1, between 0 to 6, so I'm going to change my window. That means -1 to 7, all right? And I don't know about my y, so let's go -10 to 10 just in case. All right, so graph. Okay, looks like my graph is going well, and it dips right there down below. So what that means is that it has a positive velocity and it has a negative velocity. It means it went backwards. But if you think about it, in calculus words in velocity. What this means is that it went right and it went back. So what you go forward versus what you go backwards is going to cancel each other out. But when you're looking for total distance, I want all the distance traveled, so I cannot count this as a negative answer. So you have two ways of doing this. You can find the integral from 0 to that point and then subtract the integral from that point to that point. That will give you minus a negative that will make that positive. Or there's a shortcut. You can make all of this positive if you absolute value your function. So if you want to find the total distance traveled by the particle, you can go total distance equals the integral between 0 to 6, because that's how long it took, the absolute value of your v of t, all right, dt. So what that means is that when I'm plugging it in, I can go ahead and plug that into my Math 9. The effect of this is that it's going to flip this up. So it's going to be like this graph, and it goes up. So it forces both pieces to be up above the x-axis, hence making your distance positive. So your total distance is going to be a positive value. All right. So let's see. You go Math 9 and absolute value. If you remember, absolute value is under Math. It's under numbers, and it's the first one, absolute value. And now I'll plug in my function. 2 sine of e of x over 4, close, close, plus 1, close, right? The first close is to close my e to the x. The second closing is to close my sine. And the last closing is to close my absolute value, comma, x. That's what I'm deriving it with, 0 and 6, and enter. And it'll give me the total distance of, oh, it's taking a while to think. My calculator is a little old. So, come on. Wow, this is taking a lot longer than normal. But based on my previous answer, oh, good. Based on my previous answer is 12.573. Yep, so 12.573. That would be your total distance. All right. Now, from 0 to 6, the particle changes direction exactly once. Find the position of the particle at the time. So we graphed v of t before, right? When we graphed v of t before, it changed position, it changed direction right there. Positive means it moved right, negative means it moved left. So right here at that point, it changed. So what is that point? You got to find it. Second calc, that's a 0. So I'm going to get as close to as possible. My first left bound, and let's go down under. Come on. All right, enter, enter. And my 0 is 5.1955223. Whenever you have something like this where you're using the values in getting your final answer, you really don't want to round too much because it might affect a lot more than you think. So x is 5.1955223. So what is my position? Well, position is the integral of how much has traveled, right? But don't forget, you started your position at x of 0 is 2. So you started with 2. That's your initial position. Plus the integral of 0 to that value, 5.1955223 of v of t. Right? That's how much is traveled starting from that point. So then your total for your position at that time would be, so let's see. So Math 9. And I'm going to put my v of t again in there, 2 sine of e of x over 4, close parentheses, plus 1, x, comma, 0, comma, 5.1955223. All right, enter. So there is another shortcut if you are interested. Because we already graphed it out, you could go ahead and use second calc. And there is an integral here, number 7. And it says lower limit. That means your bounding of 0. Enter. And then your upper limit is 5.1955223. Enter. And it will calculate all that area for you without you having to punch it out with Math 9. And see, we get the same answer, 12.13477. So it's up to you which one you want to do. So your answer is 2 plus 12.13477. So particle's position at that time is 14.135. Okay, that's it for number 1.